Well, that was scary. All right. So when you have a right triangle, what's that side called? If your angle that you're looking for is in that corner, this side is called the opposite leg. This side is called the adjacent leg. Okay. Back in 1803, Lewis and Clark went to explore the West. Okay. Now, when they went to explore the West, who was a Native American lady that helped them out? I don't know how to spell her name, but I know how to spell her cousin's name. Her cousin helped them navigate using trigonometry. You know what her cousin's name was? Sokotoa. Sokotoa used trigonometry to help them navigate up the Missouri and then continue on from there. Okay? And if you believe that, hey, I've got the Golden Gate Bridge off in Arizona somewhere that you can buy too for sale. Anybody want to buy it? No? No? Okay. Sokotoa was not a person. It's a mnemonic device. What's a mnemonic device? You're right on. Did you ever take sociology? No? Well, in sociology, you learn about mnemonic devices. Okay? And SOHCAHTOA is a mnemonic device. What does it help us with? Well, it helps us with sine, cosine, and tangent. Now, the sine of an angle, we abbreviate as sine of an angle, equals the opposite leg over the hypotenuse. The cosine of an angle is equal to the adjacent side of the adjacent leg of a triangle over the hypotenuse. It's a ratio. And the tangent, abbreviated tan, is equal to the opposite side over the adjacent side. Okay? So sine, cosine, tangent. Now those three functions have three cofunctions. Okay? The cofunction of sine is cosecant, abbreviated CSC. The CSC of our angle equals the hypotenuse over the opposite. The secant of our angle, abbreviated SEC, the best football conference in the nation, equals the opposite side over the adjacent. What are you doing, Mr. Bierschbach? The adjacent. What are you doing, Mr. Bierschbach? The hypotenuse over the adjacent side. And finally, we have the cotangent. Abbreviated COT. The cotangent of an angle is the adjacent side over the opposite side. So cofunctions are the what of the original functions? What do you not an inverse, it's a type of inverse, but it's not the opposite, because an opposite would be positive negative sign. Reciprocal. Sine and cosecant are reciprocal functions. Cosine and secant are reciprocal functions. Tangent and cotangent are reciprocal functions. Okay, so we're going to figure out the 6 trig functions, and we're going to just have a warm-up homework assignment here in a little bit with just 2 problems with 6 parts each. So it's like 12 problems. So here's our warm-up assignment. Okay. We'll do 2 of them, and then I'll have you do 2 of them on your own. So let's say there's a point at 5, 5. On the Cartesian coordinate system named after?
Cartesian.
No, Rene Descartes. Rene Descartes. He was famous in history too. If you ask Courts about Rene Descartes, he might actually know something about him. Bundy might know something about him too. Maybe even Ludeman too. So, all right. When you draw your point at 5, 5, you draw from that point to the origin. And then you draw from that point to the x-axis. You never go to the y-axis. Okay? So here we have a triangle. What kind of a triangle? A right triangle. Our angle is always by the origin. So we have an adjacent side, an opposite side, and a hypotenuse. Now, what's the length of our adjacent side if the point is at 5, 5? 5. What's the length of our opposite side? 5. What's the length of our hypotenuse? Thank goodness somebody said 5. Okay? Our hypotenuse is part of the what triangle? It's a right triangle, and it's actually a 45, 45, 90 in this case. But if it wasn't a 45, 45, 90, how would we find the hypotenuse if we know the 2 legs of a triangle? Oops. Pythagorean theorem. Okay? No, it's not Cauchy-Bierschbach. It's Pythagorean theorem. All right. So Pythagorean theorem. C squared equals a squared plus b squared. Okay? So c squared equals 5 squared plus 5 squared. C squared equals 25 plus 25. C squared equals 50. Square root of each side. C equals the square root of 50, which breaks down to the square root of 25. Square root of 2, which is 5 square root of 2. So it's 5 square root of 2 is the hypotenuse. So what is the sine? Well, to figure out the sine is opposite over hypotenuse, which is 5 over 5 square root of 2. Now, I'm not a math god. I'm pretty good at math, but I'm not a math god. But math gods get very, very, very angry if you leave a radical in the denominator. So how do you get radical out of the denominator? Multiply by square root of 2. The 5s can cancel, so they're gone, so it's like 1 on the top. So it's 1 over square root of 2. So if we multiply top and bottom by square root of 2, you get square root of 2 over 2. That's the sine of that function. Cosine equals the adjacent over the hypotenuse. What's the length of my adjacent leg? 5. Hypotenuse? 5 square root of 2. Cancel. 1. Multiply top and bottom by square root of 2. So it's square root of 2 over 2. Tangent equals the opposite side of the adjacent side. Opposite side is 5. Adjacent side is 5. What's 5 divided by 5? 1. Okay. Cosecant is a reciprocal of sine, so it's hypotenuse over the opposite. Hypotenuse over the opposite is 5 square root of 2 over 5. What can we do? Cancels, so it's just square root of 2. Secant is a reciprocal of cosine, so it's the hypotenuse over the adjacent. So it's 5 square root of 2 over 5, which is, again, square root of 2. Cotangent is what over what? Adjacent over opposite. What's the adjacent? Opposite. 5 divided by 5 is? 1. Easy peasy lemon squeezy. Okay? Now, all triangles aren't in quadrant 1, though. What quadrant am I in? 3. So I'm at -3, -8. If my angle's here, my opposite side is -8. My adjacent side is -3. What's my hypotenuse? Well, how do I figure out a hypotenuse? Pythagorean theorem. Thank you very much. -3 squared plus -8 squared. What's -3 squared? 9. What's -8 squared? 64. What's 9 plus 64? 73. What's the square root of 73? How does that break down? What goes into it? How many gazintas does it have? It doesn't have any gazintas. Do you not know your gazintas?
No.
Gazintas. 1, 4, 9, 16, 25, 36, 49, 64, and so on. Those are perfect squares. Gazintas. Because you have to see how many of these go into this. Go into, goes into, goes into, gazinta, gazintas. You guys, never heard of a gazinta. I swear. Cool. All right. So the sine. If this is the square root of 73, what would the sine of our angle be? Well, sine is opposite over hypotenuse, right? What's the opposite side? -8. The hypotenuse. Can we leave square root of 73 on the bottom? So it's -8 square root of 73 over 73. Look at that. Whoops. Okay. Cosine. Adjacent over hypotenuse. What's my adjacent side? -3 over square root of 73. And again, we have to multiply top and bottom by square root of 73. So it's -3 square root of 73 over 73. Tangent. Tangent is what over what? Opposite over adjacent, which is -8 over -3, which is 8/3. Cosecant is a reciprocal of what? Cosecant is a reciprocal of sine. So it's negative square root of 73 over 8. Secant's the reciprocal of cosine. So you just take this first one and flip it over. So it's negative square root of 73 over 3. And the cotangent's the reciprocal of tangent. So you take this first one, flip it over, Negative divided by negative is positive, so it's 3/8. There you go. So you're going to have a 2-problem assignment here quick. I'm going to give you about 15 minutes to work on it. Then I'm going to teach for about 15 minutes, and then I'm going to abandon you and go to the gym to help get set up for our concert. And I don't know who's coming in. Maybe nobody will come in, but whatever. But I've got to help with that.